Hello, my name is Paul Wood, Market Development Manager for Metcal. Today we are going to use National Semiconductor's LLP package and show the rework process using Metcal BGA rework equipment. The rework machine is a standard rework machine for array devices such as CSP and BGA. This machine is configured with placement on one side, reflow on the other side, and the reflow consists of an underboard heater and a nozzle which reflows the devices onto the circuit board or removes them from the circuit board to the same reflow profile as a standard reflow oven process. For component removal, the PCB is placed on the stage above the preheater in line with the nozzle, and the right size nozzle is selected for the device. In the center of the nozzle is a vacuum shaft that can remove the device depending on the size. This is the vacuum shaft that will remove the device at the end of the peak reflow zone in the machine. Once the head is aligned to the component and the vacuum shaft is in contact with the component, the vacuum is applied, and at the peak temperature, when the solder melts, the device will be lifted off the board into the nozzle. Once the component has been removed, the vacuum is closed down and the component is removed from the nozzle. Inspection can take place and normal site cleaning with solder wick and an iron can take place. This is the stencil used for the National Semiconductor LLP 16-pin. The center array here is for the die attach, and this is the I/O pads of the 16-pin LLP. For application of solder paste to the device, the new device is inserted into the stencil template. A clamp is inserted over the top to hold the device whilst printing takes place. Printing is done from underneath. The component is printed. It is now lifted out of the stencil plate once the clamp has been removed. After the component has been printed with solder paste and the clamp removed, the template is inserted into the tooling, ready for the device to be picked up centrally on the machine. The component will be picked out of the template with a vacuum and lifted up, template moved out the way, and now alignment of the component to the circuit board is done with an image overlay of the device to the circuit board with a split field vision. X and Y is done on the circuit board, and rotation of the device if necessary is done on the component. Once component is aligned to the circuit board, placement is done to the PCB. When the component touches the board, the vacuum switches off and placement is complete. After placement, the board is shuttled to the reflow position for the component to be reflowed back, and the nozzle is removed down to the device. The reflow of the device back on the circuit board is carried out in 3 stages of heating: preheat 1, soak, reflow, and cooling. This duplicates the reflow process in a production environment with a full convection reflow oven. The 3 plots will show the component temperature, the temperature of the device, and the heater's top and bottom. The green one is the nozzle, the brown one is the underboard heater, and the purple is the temperature of the component. Once the device has been reflowed back onto the circuit board, the head is removed and the reflow process is complete. For localized heating of the device, different size nozzles are available for different size packages so that local heating is available if required. Thank you for watching. This concludes National Semiconductor's LLP rework process.